Thank you, Marissa, for a nice introduction. My name's Duncan Firth, and I am an architect from New Zealand, working out of Bangkok. I work on environmental, sustainable design and working on buildings which connect to the climate. So I'd like to start off with the initial premise, which is connecting the human world to the natural world through environmental, sustainable design, the good technology. So what today's talk is going to be about is, and which relates to what it is that I do as a professional, is relating houses to nature. And there are four fundamental areas which I'm going to talk about today. First one is climate, environment, human well-being, and then at the center of that is affordability. So I just want to quickly run down on the key areas that I'll be talking about. Climate, all countries, regions, and sites have different climate types. Environment acknowledges and incorporates local site conditions into a design. Human well-being, the purpose of building is to provide shelter, comfort, and psychological well-being for humans. Affordability, what we design has to be affordable and connected to the real world of economics. Climate, point one. So this is the Köppen climate classification diagram, which represents all the different climate types in the world. Every country, region, site has a different climate type. Out of that comes a different design response each time. Thailand, for example, is tropical. New Zealand, where I'm from, is temperate. By designing to climate, we sustainably and efficiently utilize nature rather than resisting nature. The above diagram represents a building that I've designed and how it works with the different seasons of the year. Summer, it's designed to shade the building, cross-ventilate the building. Winter, it's designed to bring sunlight and warmth into the building. But the key point is designing a building which relates to its local climatic conditions. It connects to nature. Thailand is predominantly a tropical climate. Therefore, buildings require shading, natural airflow, and cooling. New Zealand is a very cool, temperate climate. Therefore, buildings have to be warm. Point being is that climates are different. Buildings need to be different for each climate. Mahanakorn building is a beautiful architectural building, and it's done a lot for the Bangkok city line. But this building could be a building in Sydney, it could be a building in Auckland, it could be a building in London, it could be a building in Dubai. It has no relation to its environmental conditions. An average high-rise glass tower in Bangkok will use around about 140 kilowatt hours per square metre annually. That's a lot of energy. If you look at your power bill at home, that tells you how much energy you use in a month, and you can work that out over a year. Fundamental stuff. A Thai middle-class house at around about 300 square metres will use around 55 kilowatt hours per square metre annually. In New Zealand, by the way, this is not my design work, these are just sample houses. A New Zealand house, a typical New Zealand middle-class house will use around 45 kilowatt hours per square metre annually. And we typically refer to these types of houses as wedding cake houses, trophy houses, all show little substance. Totally insane energy use. And the reasons why are that as a consequence of this inefficient energy use, we have to build more dams, we have to rely on complicated green technology to solve these problems. And it does not have to be like that. There are some solutions. This is a New Zealand house, and this is designed around passive energy efficient design. Houses which engage the environment. With this house, we can achieve between 15 to 25 kilowatt hours per square metre annually. So compared to the three last examples, this is 70% less energy compared to a non-design environmental house. This uses minimum amounts of smart tech to to solve bad design problems. But designing for local climates, we sustainably and efficiently utilize nature rather than resisting nature. Environment, point 2. Environmental design acknowledges and incorporates local site conditions into the site and layout of a building. It's looking at a site and seeing what is unique about that specific site. How is the architecture going to respond to that? Such as orientation, seasonal sun paths, seasonal winds, microclimates, and unique environmental conditions. These all influence the design of the house, and it enables us to design out complex technologies or minimize the dependency on these technologies. At the moment, somehow we think that technology is going to save us, and it's not. It's part of the solution, but it is not the answer. The design of a building has to come from its unique, specific site circumstances. Each site is different. This is another house in New Zealand, and what we're looking at is optimizing and minimizing the amount of technology that we use in there. And what we've done here is we've essentially designed out the air conditioning system. And what it comes down to is correct insulation technologies, glass technology, understanding how the seasonal winds are going to work at different times of the year, different times of the day. And what you see above the corridors are essentially ventilating slats. And they essentially allow passive airflow to circulate through the house. And from that, as a consequence, we don't rely on a mechanical system to distribute air through the house. So it's just using the physics of nature to essentially distribute and cool the house without getting too complicated in the technology that we use. Keeping buildings cool and warm is what we need. Tropical climate is all about that. And it's essentially designing buildings which are based on natural airflow and understanding these seasonal airflow patterns in an environment and allowing a house to connect with that, and doing so, we minimize the amount of air conditioning that we use. And this could mean for a Thai house during the daytime, you're not dependent on aircon to cool down the house. At night time, sure, you're going to need kind of aircon when you go to bed, but during the daytime, it's quite easy to design out your dependency on aircon if the house is correctly orientated to the sun, if it's correctly orientated to your prevailing winds, and if it's correctly designed so that airflow will move through that house and passively cool it. From this, buildings become super energy efficient, requiring minimum amounts of heating or cooling. And this creates a comfortable living and working environment. So at the heart of this is human well-being. The purpose of building is to provide shelter, psychological well-being for its occupants, comfort, social connectedness, and ultimately happiness. I'm just going to go back. If we're unable to achieve that, then that questions the whole purpose of why we build a building. What's happening these days is a lot of buildings, there's a lot of cut and paste and copy, and buildings become quite iconic and very design orientated, but at the expense of the environment. And we are very dependent on basically technology to solve, I guess, non-environmental design. The World Health Organization suggests that internal temperatures are between 18 to 21 degrees for occupants to function comfortably. Thailand, it might be a little bit different because we're acclimatized to a tropical climate, but I suspect, personally, I find it comfortable to work in an environment between 22 to 24 degrees. Again, how this relates to Thailand is that because we're so dependent on technology to cool down for example, a high-rise structure, is that we rely on an abundance of technology to solve these inefficient design problems. Back to human well-being. We have to care about human well-being and people that use buildings. Without this, then we are designing for the wrong reasons. Affordability. What we design has to be affordable and connected to the real world of economics. Without this, not much is possible. By being realistic about what we want, how much a building costs, we can design a building that is economical and that responds to its environment. If we have high expectations, or if we build a building for status, those are the wrong reasons to build. When we start to become realistic, when we start to think about affordability, then everything becomes more realistic. And these ideas of creating the good technology become more viable and more real and something that we can do, rather than just kidding us. Modesty is a big part of it. Being realistic about design and economic realities allows for a greater chance of environmental success and the design of a house, and ultimately, the good life for many people. Conclusion. So, back to the premise, connecting the human world to the natural world through environmental, sustainable design and thinking. The current situation all over the world, but I'm going to focus on Bangkok, is that what we have done as a species is essentially we have conquered nature. We have subdued nature. And this is largely seen in all our cities, whether or not that's Bangkok, Auckland, London, Dubai. This has resulted in an overall disconnection from nature, or by nature becoming something abstract to us. It's not real, it's disconnected. We look at it through the windows in our glass towers or in our glass windows in our houses. And a good example of this is the leader of the free world. Donald Trump he's a pretty easy target, but he's a classic case of a climate change denier. He lives in a 72-story tower in downtown central New York, and I don't actually think he actually understands the fundamentals of what climate change is. But regardless of that, what it is a reflection of where we are at as a society, as a civilization. And all Donald Trump is doing is reflecting back to us who we are and how we are living. So, we have all the access to climate data, smart technology, environmental principles to solve these technical design problems. If we are able to connect buildings to nature, then what that does is it reduces our dependency on complicated technologies, or minimizes our dependency on these complicated technologies, and it allows us to basically forge a clearer and better connection in our buildings and our design with the natural environment. Thank you very much.